Assalamu alaikum students. Welcome to new round of English text. Today we are going to read unit number 8 on the crust. First, I will introduce you to the theme or summary of the unit. But before reading, highlight and underline the difficult words and learn the unit for dictation. The passage describes the Earth's plates and how geologists have explored the structure of the Earth's crust and its evolution over time. Originally, a single continent formed millions of years ago. The crust gradually broke up into plates that still continue to drift slowly in different directions. Oceans and seas have formed as a result of this phenomenon. Hot materials under the mantle pushes and move the plates, sending out shock waves that are felt as tremors on the surface. When plates get locked together and then separate, the sudden jolt can cause a major earthquake. Now open page number 94 in your book. Unit number 8, Plates on the Crust. What do you think an earthquake is? An earthquake is caused by a sudden slip on a fault. When the stress on the edge overcomes the friction, there is an earthquake that releases energy in waves that travels through the earth's crust and cause the shaking that we feel. Do you know what happens during an earthquake? Earthquakes are usually caused when rock underground suddenly breaks along a fault. This sudden release of energy causes the seismic waves that make the ground shake. During an earthquake and afterwards, the plates or blocks of rock start moving, and they continue to move until they get stuck again. The Earth's layers. The Earth's hard outer layer is called crust, extending only from 5 to 50 kilometers deep. It is remarkably thin compared to the 6,000 kilometers spanning the Earth's surface and its center. Point number 2. About 30 years ago, geologists discovered that the crust is not one solid piece. Instead, it is split into separate slabs that are now commonly referred to as plates. The plates float like giant rafts, one on top of the lowermost layer. The crust and upper part of the mantle, which is the layer immediately below the crust, together form the lithosphere. Point number 3. About 300 million years ago, there was only one large continent that geologists call Pangaea. Gradually, the continent began to break up into separate plates. Since then, the plates have been moving about in all directions. Places that were once near the equator are now much further north. The fact helps to explain why limestones containing coral fossils is found in places where it is now far too cold for coral to grow. Now move on to page number 95. The crust now has about 15 large plates and several smaller ones. They move very slowly, about 2 to 4 centimeters every year. This does not seem fast to us, but geological time is measured against millions of years. Geologists, going by their own calculations, believe that the speed is strong enough to open up an ocean 2,000 kilometers wide in about 50 million years. In fact, the Atlantic Ocean has opened up in this kind of a time frame. It is thus evident why some of the older rocks, such as coal, are found to be of the same kind on both sides of the Atlantic Ocean. Why the plates move. Point number 5. It is quite evident that a phenomenon is taking place inside the earth and shifting the plates around. It is hard to find out the exact nature of this phenomenon, as it is not possible for anyone to go that deep inside. The molten rocks thrown up by volcanoes contains clues about what may lie deep under the crust. Shock waves from earthquakes also give indication about the inside of the earth. Point number 6. The inside of the earth is so hot that rocks tend to melt and flow. However, they remain partially solid and move only very slowly because of the intense pressure all around. Currents of hot material move towards the crust from inside the mantle. When they reach the mantle, they separate under the crust and flow along in different directions. These streams of hot molten materials are called convection currents. The convection currents is in the rocks. Now move on to page number 96. Push the plates above them and set them moving. As the plates move, they crash into each other, move away or slide past each other. The pressures that cause these movements are enormous and cannot be stopped. Point number 7. The plates move slowly, grinding against each other and sending out vibrations through the rocks. These vibrations are felt on the ground as tremors. Point number 8 and the last one. Sometimes parts of the plates get locked into each other and stop moving for a while. On such occasions, the pressure to move keeps building up until the plates jolt forward again. All the energy is suddenly released and there is a major earthquake. That's all for today. Allah Hafiz.